Yeah, anyway, my name is Sam Edwards, as I said. You can follow me anywhere online as Handstand Sam. I'm pretty good about stealing that handle wherever I go. And this talk is called A Screenshot is Worth 1,000 Words, specifically for Espresso testing, but this sort of idea carries across any time you're doing UI testing, whether it be web or iOS or anywhere else. I'm a lead developer at Capital One. I'm also, as of 2 days ago, an Android GDE, so I'm very excited about that. Thank you. And at Capital One, I work on the wallet team, and I'm one of the people that helped set up all of our Espresso testing efforts that we had done. We had previously done Appium, and so I kind of helped do that. And all the opinions in this talk are my own. So a quick poll, raise your hand if you've done testing. All right, and keep it up if you've done Espresso testing. And keep it up if you've done Espresso on continuous integration. And anybody done screenshots? All right, good. We're all here for a reason, but I'll have to talk to you later. So I'll just do a quick what is Espresso, so anybody that hasn't done it can know what it is. I will talk about screenshots, why we want to take screenshots, how, when we want to take screenshots, and what is the cost of actually doing them. I'm going to talk about how we want to get screenshots for free and like a trick to do that, and then other tips and tricks. So this is a little bit of a condensed version. So this is 25 minutes. There's a full version that I did at Joy-Con New York City, so if you want more details later on, feel free to talk to me or to check out that version online. So luckily, we don't have to watch a Nicolas Cage movie. We're going to do Espresso in 60 seconds. All right, what is Espresso? It is a library provided by Google for Android UI testing. It's built on top of the Android instrumentation framework, and it's aware of the idle state of your application. Idle state means that nothing's actually processing in the app. You kind of come to a state where the phone's now in idle state, and now you can check something. And this is very important in UI testing because you want to wait until it's done processing everything, and then at that point, check to see what the screen looks like. Because it is aware of idle state, it is very fast. Not only that, but Espresso is easy to read and write. There's 3 things you need to know when you're doing Espresso. First, you find a view. So this is any element on the screen, any box up there, whether it be a text view, a list view, anything like that, and there's view matchers to help you out on that. So you find this view, you now have a view match, a view itself. Then on that view, you can do 2 things. You can perform an action, being like a click, or typing text, or scrolling, or you can do an assertion where you can go ahead and make sure that it's visible, or it's not displayed, or something of that nature. So that's Espresso. Actually, Espresso is really easy. It's just these 3 things. But there's a lot of complexities that go into set up Espresso tests and then with screenshots. So we'll go into screenshots in this. Another challenge that you find with Espresso testing is disabling animations. It's not hard to do, but it's definitely a gotcha. If you're getting started, make sure that you disable all the animation scales on your device. Otherwise, your test might fail because it's not ready yet. And as I said, Espresso is aware of the idle state of your application. So never use thread.sleep. That basically means, hey, application, you should wait for 10 seconds, because I think that's how long the server call should happen. Instead, there's a thing called an idling resource that you can use. And there's also things, you can also leverage the async task thread pool, which is on Android, because the Espresso framework knows to wait for anything in the async task thread pool. And idling resources capture anything else that's not part of that. So if you have any action you want to wait for before you do your Espresso testing, you can create a custom idling resource. But never say wait for 10 seconds. It's something that will get you in a trap, and your code will get a lot slower that way. OK, so we're all here for screenshots. Why do you want to take screenshots? I have 3 main reasons, and I'm going to go through each one of those. Number 1, you want to see what's being tested. This is a UI test, so obviously there's user-facing things that you want to see. Right now, if you run your Espresso tests, it's going to look like this. You'll have your console output, and it's a UI test. That's great that it passed, right? Like, that's important in continuous integration and so forth, but you really want to know what is happening in your tests. So if you run it in Android Studio instead of via the command line, it has a nice little way of showing you what the class was and then what the name of the method was that was tested. However, you still don't have much context. It's just a prettier way of displaying that console output. I recommend, if you're doing a lot of tests and you're running them, to use a reporting framework. This is a screenshot from Spoon, which is one of the reporting frameworks out there. And then you get a little bit better where you have the method name, and then you have logs for the device and maybe screenshots if there are any. And if you actually do have screenshots, it looks like this. So this is a test for the welcome screen pages. And so typically if I said, oh, I have an Espresso UI test, and it tests to make sure all the welcome screen pages have the correct content, that when I do a swipe, then I make sure I get to the correct page, and I end up on the welcome screen. This is not something too crazy, but it's something that you want to make sure works in your app. And if you have screenshots taken along the way, and you can see those when your tests are executed, you know exactly what that looked like. So you can see what's being tested, and that means anybody else in your team can see what's being tested. Number 2 is diagnosing failures. Espresso testing, as I said, is easy when you write the code like that, but it's complex when you get into it. So trying to figure out why your Espresso test fails is very important, and screenshots can help you diagnose failures. Because just like before, when a test fails, you get more console output. And it's very detailed. It's probably 1,000 words of console output. But if you actually had the screenshot to go along with that console output, you can compare the two together. So in this case, the test failed because I was expecting all capital words or capital letters for the word done, but it wasn't. So it had an assertion failure, and it went ahead and did that. So, I see why it failed. If you want to do screenshots on failure, it's so simple in Espresso. All you have to do is use the Espresso's global failure handler. So you say espresso.setFailureHandler, and then you go ahead and you provide an implementation that says, when there's a failure, take a screenshot. That's pretty simple. What you also want to do, which is in there, you want to go ahead and use the default failure handler. This will generate the correct tree structure of all the UI elements, so you still get all that information. And you also want to go ahead and you want to throw a runtime exception, so your test stops. When I first did this, I didn't throw a runtime exception, so my test would fail and take a screenshot at that point, but it would keep running, and that wasn't a desirable thing. So make sure your test stops if it fails. This is an example of a failure report. So if you went ahead and ran your tests and you just had screenshots on failures, you'd go ahead and have your information about what the failure was, but then you also have your associated screenshot with it. So it gives you all that context of what was actually happening when that failed, and because this is UI testing, that's very valuable. Number 3 is to share your tests, and I feel like this is almost the most important when it comes to screenshots. No one sees the value in your tests yet. So your bosses, your product owners, your designers, your manual testers, even maybe other developers on your team, they don't really care. And the reason why they don't care is because to them, it's just, your tests aren't doing anything, and it's just console output. So like when they look at it, they see that first view that we just saw. It's console output. You said you ran a test, but that doesn't mean anything to me. So what screenshots allow you to do is to communicate what you're doing as a developer and share that. And as we've heard in other talks, it's very important as developers to take what we're doing that's very important and have it so other people can see it correctly. And so this helps enable communication with other people that don't speak code and console output. So my thing is, let everyone see what's being tested. With screenshots, it's our vehicle to go ahead and show other people what we're actually testing within our UI tests, and that's super valuable. This is kind of an analogy, but it's just pretty much to say that user interfaces are visual. We saw that one big line of 1,000 log outputs. But here, if we were to have an exercise where we had a visually disabled person and we had the Mona Lisa painting, could you even imagine describing that to somebody? How would you give them a pixel by pixel representation of what this looks like? Is it a woman with brown hair with an olive background? Probably the most specific way you could do it is to go by each pixel and give her the RGB values, and then they could go ahead and figure that out. But that would be a screenshot's worth 1,000 pixels? I don't know. Just kind of came up with that one. What's also really awesome about screenshots on Espresso tests is that they run on different sized devices. So on the left, you have a small device here that's probably your typical phone. And on the right, you have a tablet-sized phone. Now, we use the exact same Espresso test, and we ran it on both of those, recording screenshots. And we can see the login page here and the login page on a tablet. And so this is super important, because sometimes you don't design for a tablet user, right? Or for other screen shapes. And so by doing this, you have a window into what your tests are doing. Here's an example report for one of our tests, a smoke test that kind of goes through the whole app to make sure everything's working. So this is a small device on top and a large device on the bottom. I won't make you kill your eyes, so we'll zoom into one. But on the left, we have our terms of an agreement, our terms and conditions, and same here on the right. And as you can see, it's very different looking on the tablet and the mobile device, but I'm able to see those and share what that looks like to people without having to have them go get a mobile device and then a tablet and go run all these things. I can send them this report, and they can see how it looks on both. And then our designers can give us feedback, products can give us feedback, and sign off, even QA testing, to say, hey, we understand that this is looking correct. So Android embraces differences. This whole community is amazing. It's all be together, not the same, right? We all come from different backgrounds. But we all love Android, and we want to make this a great platform to develop on and to use to make our lives better. But the problem that comes up when you're writing Android applications is that you have to deal with different device sizes, like we've talked about. But not only that, but the OS version. If you're still having to support KitKat or Ice Cream Sandwich, all the way up to the newest things, and this only goes up to Lollipop. We still have things way after that. But yeah, so we have the different OS version, different device types. So you have Samsung's, HTC, Motorola, and then you have different languages because Android is available across the globe. Sometimes you want something that's available in multiple languages, and so your application will actually look different in each one of those. There's some languages that have left text justification, others with right, and so with having screenshots, you can go ahead and see what that looks like without having to manually run all of them. So I've talked about test runners and HTML reports and how I prefer that over console output and over like the view in Android Studio. The way it actually works, I thought was black voodoo magic in the beginning, but now I understand what's happening. When you run Espresso test via the command line, you run the instrumentation command. And all that this report runner is doing is it knows the test it wants you to run, so it's going to run each one of those instrumentation commands, and as it goes along, it's going to collect all the logs that are coming from ADB, and then at the end, it'll copy the screenshots from the device and then generate an HTML report. So there's no black voodoo magic, it's just getting the instrumentation results, it's collecting the logcat files, and then it's going to copy an ADB pull from the device to get all those screenshots. But it's nice they do it for us, we don't have to. So Spoon, as I've talked about, is kind of the standard for what people have used for a long time. There's now Composer, which is another one that came out that uses the same file structure. The developers of this just had different ideas of what they wanted their reports to look like. But both are valuable and both have their own pros and cons. But both are out there. This is an example with a Spoon test runner. If you wanted to use it, if you did instrumentation commands by hand, they're going to be very complex. But Spoons allows you to do things like test sharding, where you have, let's say, 30 tests across 3 devices, and it'll run 10 and 10 and 10, and then give you the results back. If you actually ran the instrumentation commands to do that, it's a lot. But in Spoon, you can just say shard, and that works. So you can do also tests in parallel, so you can have 2 devices running the same test at the same time, kind of like the report you saw earlier. And all you do is you just say java-jar, the Spoon runner, and you give it your APK and your test APK, and it will run. And obviously, there's more advanced commands, like we said, that will pass in, but all of that magic of it generating the test report is happening within its jar file that has like everything that they need to do that. Okay, so we talked about how we want to, we've talked about why we want to take screenshots and why it's important, but how are we actually going to do it, right? I can't just talk about it if we don't say how we're actually going to get this done. And so there's 3 libraries that are out there right now that are primarily used for actually taking a screenshot on an Android device. Spoon comes along with one. Falcon is another library, and UI Automator is here. This slide is here to show the visual differences between each one of them, because this is actually the same exact screenshot across all of them, or the exact same state in an Espresso test. However, you do see that they're different. The primary things that you'll see is that there's no context or menu on the first one, and that's because Spoon, the way it's implemented, doesn't capture system dialogues, like if you had an alert dialog come up, or these sort of things. So the way it's doing is it just grabs the activity and then tries to traverse down and take pictures of all of that. Where Falcon, it has that same implementation, but it's also able to capture the system dialogues and kind of smashes them together. So what I'm going to do is just kind of get rid of Spoon, because if I take a screenshot during my test saying it failed and it couldn't find the refresh item, and it gives me this screenshot, I don't have the context of what I wanted. So while it is valuable and it's like a more simple implementation, it doesn't give me the information I needed. So as far as I've gone, I don't use that implementation. UI Automator is available as part of UI. So it's available from Google, but it's only available from platform 18 and up. If everybody's in a dream world, we're all developing a Lollipop and up, but we're probably not. So UI Automator is great, and it actually captures, if you see small details in the very top here, that you're connected on 3G and the time of day, as well as the virtual buttons on the bottom. So these are something that Falcon doesn't get because it's only still interested in our part of the application. I kind of like that though, because I don't care what time of day my test will run, and the virtual buttons I know are going to be there. So I can kind of, if I wanted to, I could write a script to actually compare the 2 bitmap files to make sure that these were actually the same. So if you're going to use Falcon, there's a library called Falcon Spoon Compat, which allows you to use the same syntax that you would have used in Spoon, except you say Falcon Spoon instead of Spoon. So you just say take screenshot, you pass it the activity, and the tag, which is like how you want to label that screenshot, and it will go ahead and save it to the disk so that the report can pull that off. With UI Automator, you have to do a little bit more work because it doesn't know about Spoon's reporting structure. So you have to go ahead and take the screenshot and then actually save it to the file that you care about. As I said, this is only available in 18 and up, but this is kind of the way most people do it because you get everything. I'll show you a little bit later on that says maybe this still isn't the best because of performance reasons. Other alternatives you can use, which are pretty much the same implementations as we saw there, but packaged in a different way, are so if you're going to do screenshots on Firebase Test Lab, there's a tool that you have called Screenshotter Library, and that saves all the images on the Android device in the directory that they needed to pull it from. And there's also Fastlane Screen Grab. So that's a tool from the Fastlane stack that you can use. So if you were to write a typical Espresso test right now, it would look like this. You'd have a login activity test rule that launches your login activity. And what you do is you grab the field with the ID username, and you type the text SAM. Then you go ahead and on the view with the word login, you go ahead and perform a click. And then you'd assert that you actually got the home screen. So a pretty simple Espresso test. If we want to add screenshots to it, we can just say take screenshot coming through. So we entered the username, we're clicking login, and then the home screen was shown. So now I have context of when these things actually happen. But you have to do this in every single one of your Espresso tests, and so it gets very verbose. So as I mentioned, I'm going to show you a hack to get screenshots for free. And this is via a robot testing pattern. So kind of describing what that is you have all your tests on the left there, and you have tons of them that all kind of interact with your app. On the right, we're all aware of like MVC or MVP or all these other things. In this case, it's talking about MVP, but the goal of it is to separate out concerns to give you an architecture so that your code is clean and decoupled. Right now, if you wrote all these tests and your one view changed, every single one of your tests is going to fail because they all have their own with ID or with text in there. And so it makes you go update all of those tests. The benefit of having architecture, as we see on the application side, is the what you have and the how it's being done are separated, and that's how it's working there. In your test right now, the what and the how are all coupled in. So it's like writing everything in your activity and just baking it in there. What we want to do then is we want to separate that out, and we want to add a robot in there, which will show how things are done, and the test just tells the robot what to do. So the test itself is saying what I want to do, and then how it's actually be done is via the robot. So now we have a UI test architecture. The view is the only thing we can see from a testing perspective. Like we can't see your model and presenter because that's like inside of your app. So you'd have your test, which describes this kind of the same way as if I'm telling you over your shoulder, like, hey, click on the login button and then do this. Like it's a very descriptive way of doing that. And you're telling the robot what to do, who's then aware of how to perform that action. And each time the robot does something, it's just going to take a screenshot. So like that's what I'm saying, screenshots for free. These actions are going to be performed by the robot, but it's also going to take the screenshot. So now you have all these tests. They're all using robots, and they're interacting with the views. But when your view changed, you only update one thing in the robot, and then all your tests magically work again, assuming it's a small change. So what does a test look like when you actually use robots? Here in the bottom, this is the same test that we had before. So we use the builder pattern so we can just chain calls together. But we say login robot, my username is Sam, log in, and assert the home screen is shown. So as you can see, this is super readable. I know exactly what's being tested, and then all of this Espresso stuff happens. If we look closer, you can actually go ahead and define matchers from Hamcrest without any performance overhead in the beginning. So what I've done here is inside of my robot, contextually, I know that a username edit text is going to be the username edit text on the home screen. I don't have to worry about one if there's like a settings page or I want to update my username or anything. I only care about it in this one context of this one screen. And so I can define like a matcher up top that I can use anywhere else below. So when one element changes, like one property, we only have to go and update this one spot, and then all the methods that we have in our robot refer to these variables. So it's just another way of keeping your code a little more clean. So for example, that username method where we passed in a string of username, we'd go ahead and we'd find the view, we go ahead and then type in the text, and then we take a screenshot saying that the username had been entered. Next, we'd go ahead and make sure the login button is actually there on the screen. Then we take a screenshot, and then we go ahead and click the login button. Now, I'll go into it in a second, but it's kind of weird. Like, why do I need to go ahead and assert that it's displayed if I'm just going to be clicking on it later? And the reason is for your screenshot. Your screenshot is not caring about Espresso's idle state. It's just going to go ahead and take the screenshot whenever. So you have to tell it to wait for the login button to be shown. And then if that's the case, your screenshot will actually show the login button. Otherwise, it might be some loading screen before or something. And then finally, we have the assert home screen shown, which is just going to find the view, home screen, and then make sure it's displayed. And right after that, we say the home screen was shown. So these are the rules I was talking about that me and my teammate, Nick Caperso, came up with about when to take screenshots. There's two sorts of things. There's just asserting something is there or something that's on the screen statically. And there's also actions that you're going to do that are going to affect the state of the screen and maybe change things. So when it's something that's just an assertion, making sure it's there, go ahead and say beforehand, make sure it's displayed, and then take the screenshot. And that's the reason I just told you, is you want to make sure it's there before you take your screenshot. If you're going to perform an action on it, you want to go ahead and make sure it's there as well, but then you want to actually take the screenshot before you log in, or before you perform an action. And so I always have like a future tense or an action saying I am logging in. And the reason why I have to take a screenshot here versus after clicking the login button is because I might be somewhere deep in the app by the time the screenshot's actually taken. So it's just kind of a rule if you're going to add screenshots that it's kind of nice that you always get the screenshot you want no matter what order of tests that you want to write in. Okay, so we know how to take screenshots now. We know why it's valuable. Okay, well, you told me about some libraries, but which ones should I use? So I'm going to give you some of the performance costs of different libraries and different techniques. One here is execution time. So I realized, and this graph might be a little weird, but the one on the left has no screenshots being taken at all. The second column is using Falcon, and the third column is using UI Automator. And then the lines that go across are the smallest device, a Nexus 5, and then a high resolution device. So it's basically the size of the screenshot that we're going to be taking. But what you can see is that Falcon is always a little bit faster than UI Automator. And I say a little bit, but if you look in this case, it goes from 15 minutes to 19 minutes on this top line. So that's a 4-minute difference in a 70 test that were run. So that can actually add up. So even though you don't get the soft nav and you don't get the title bar, Falcon's pretty nice. Like it could be, it's up to you, but that's just something to know. Your report size, no screenshots on the left, and then you have the Falcon and then UI Automator. As you see, the size is exactly the same. It's the same exact resolution on the screen. It's just the amount of time that it takes to create that bitmap file. So when should you take screenshots? Like we've talked about how you can do it, some benefits, but I would recommend always take screenshots on failure, but don't always take every screenshot. So by default, if something fails, take the screenshot and then you have that context. But otherwise, you saw that the performance overhead here, if I go back, it kind of shoots up as I take screenshots, right? I wouldn't recommend taking them all the time. However, you do see this bottom line that doesn't go up very much, and it's still taking screenshots. It's actually running an emulator on MDPI resolution, and that makes the screen like a lot smaller, right? So there's less pixels to capture. If you think about it, if you're watching some Disney movie like The Lion King, right? And you watch it on one of those old set-top boxes that like kind of, you could still watch the movie and you get everything out of it, you know that everything was there. Or you could watch it on a new Blu-ray player and it would be really large. Both of those represent the same screen and you can see what you want to see, but it would run a lot faster and take a lot less information if you took it on the old screen. So that's basically what's happening here where I'm recommending an MDPI device. So I'm saying use low resolution emulators and so forth when you want to generate product reports for design teams. Obviously, if you need it on a specific device or something else, it's worth the performance overhead. So use screenshots wisely. As I said, like we don't want to take them all the time. Ideally, when you have it in there, when you say take screenshot, have it be programmatically configurable. You want to make it so that you can just take it when failures happen, or you want to turn all of them on or turn them all the way off. And ideally, you want to change this without recompiling. Creating your test APK and your normal APK, typically in continuous integration, you do this once. But if you want to go ahead and run this in different ways, you could specify different instrumentation arguments that you're sending into the test runner that then you can respond to. So anywhere in the test runner, you can say, what are the instrumentation args? And in this case, we use one called screenshots, true or false. And depending on that, we know whether to turn screenshots all the way on or all the way off. So Nick and I have been working on a project called Easy Screenshots. We haven't been able to open source it yet, but we're working on it right now. It is coming soon, and let me tell you what it's going to have. And hopefully it would be like end of year by the time it's out. So you'll get screenshots for failure for free. I know I said it's pretty easy with what's there, but it's not built in, right? So you get that for free. By default, screenshots are taken on failure only, but you have the ability to programmatically say whether you want them to be taken all the time, failure, or none. And you can do this via instrumentation arguments, or you can do it programmatically. And then it's configurable. As I said, Spoon is one reporting framework. There's one for Firebase Test Lab. There's other ones. The only thing that really changed is where you're saving these files on the device, like what the SD card path is and so forth. So there's two configurable options. One is the reporting framework's like structure on disk, and the second one is what is the implementation? Do you want to use Falcon or whatever else? So we default to Spoon as the reporting framework, and we default to UI Automator and Falcon because that seems to be the most transparent thing, but it's all going to be baked in, and all you're going to have to do is just say easy screenshots.take screenshot wherever you are, and it'll just happen for you. So hopefully get that out there to make this a little bit easier for everyone. Yeah, a screenshot is worth 1,000 words. My name is Sam Edwards. Follow me online at Handstand Sam, and as you saw in the picture, it is possible I actually can do a handstand, although not very well. So thank you very much. I'll be around, and feel free to grab me and ask any questions. Thanks.